Recently, in one of my weekly live streams that I do every Monday night at 5 o'clock Pacific time, I talked about finding the derivative of a specific function, which involved using both the product rule and having to find the derivative of a logarithmic function. These are both things that are going to be pretty important for you to understand as you learn calculus. So I wanted to go ahead and show you that example taken directly from that live stream in its own separate video. So that's the type of example we're going to be going over in this video. If that's going to be helpful for you, be sure to stick around to the end of the video so both logarithmic derivatives and product rule derivatives can be made a little bit easier for you. And I do also want to point out both of these things are on my free Calculus 1 study guide and my complete Calculus 1 package. If you want to check those out, the links to both of those things are down in the description. But without further ado, let's go ahead and jump into the example and I'll show you what I'm talking about. So first one here, we're going to find the derivative of y equals x cubed times log base 2 of x. So as with the other product rule examples that I've talked about, really when you're doing any product rule problem, and this is going to be the case for any product rule example or any product rule problem, you really just need to figure out what are the two basic components of the function that you're taking the product of. So in this case, it's pretty clear based on the fact that we have this multiplication sign here. There's two components that we're taking the product of. We are multiplying x cubed and log base 2 of x. So essentially, you just want to call one of those one of your functions and one of those your other function. F and G are probably the two most common letters you'll see for that. It really doesn't matter what letter you call it. What's important is that you know which are the two components that you're taking the product of to get this full overall function. So in this case, it's going to be x cubed and it's going to be log base 2 of x. Then the product rule says that we need to find the derivative of these two things. So in this case, if we're calling this f, we would need to find f prime, and if we're calling this g, we need to find g prime. So the derivative of this function here, x cubed, that's pretty straightforward. We can do that just using the power rule, which is also on my Calculus 1 study guide. You basically would just leave your base x as x. You bring your power down in front. So you would bring your 3 down in front of the function, making it a coefficient, multiplied by x, and then subtract 1 from your power. So lower the power by 1, giving us 3x squared. Now for the derivative of log base 2 of x, that is a little bit weird. Well, I don't want to say weird. This specific thing, basically how to find the derivative of log base a of x, is one of the formulas on my study guide. How to actually do this though, if you don't want to bother with memorizing a formula, what you want to keep in mind is one of the log properties is that you can rewrite any log where you have log base something of something else. You can rewrite it in the form of other logarithms that have whatever base you want it to have. So log base a of x can be rewritten as log base whatever you want. So let's just say log base, no, let's not say y. Let's say log base b of whatever you're taking the log of. So in this case, log base b of x over log base b of whatever your old base was. So in this case, a. So basically, the base of these two logs is the same. And then you have, what was your base is now the log on the denominator. What you're taking the log of is now what you're taking the log of on the numerator. So how you can easily remember this is whatever is kind of lower here, whatever's your base, whatever's written lower goes on the bottom of the fraction. Whatever's written higher goes on the top of the fraction. The base then becomes whatever you want. You just need to make sure that the base of these two logs is the same. So as long as this b is the same on both these logs, this will be true. And what that tells us is instead of taking log base b of x, we could say log base e, the known, Euler's number e, which is roughly 2.71. But that's not really, important what that number is. What I'm trying to get to here is that log base e is the same as natural log. So basically this is natural log of x over natural log of a. So now what you want to kind of notice is natural log of a a is just some constant. A is just whatever this base is. In this case, we have a equals 2. So what we can do instead of saying a here, we can just write log base 2 of x. And then this would be a 2. So basically, log base 2 of x is the same as natural log of x over natural log of 2. Well, since 2 is some number, 2 is a constant, natural log of 2 is some number, right? We could plug natural log of 2 into a calculator and get some number out. What the actual number is not important, because what we want to think about is how do you take the derivative of natural log x over natural log of 2? Well, what you can do is you can think of natural log of 2 dividing by natural log of 2 can be rewritten as 1 over natural log of 2 times natural log of x. Right? This function right here is the same as this function right here. So what that tells us, natural log of 2 is just a constant, because 2 is just a constant, therefore natural log of 2 is just a constant, therefore 1 over natural log of 2 is just a constant, right? This whole thing right here, 1 divided by natural log of 2, could just be plugged into a calculator and we would get some decimal number. So the derivative of some constant times natural log of x would be the same as this constant, 1 over natural log of 2, times the derivative of natural log of x. And that's just basically a property of taking the derivative of some constant times a function. It's the same as taking that constant times the derivative of that function. Well, the derivative of natural log of x is one of the kind of standard derivatives that you probably want to just memorize. It's going to be much more kind of complicated to explain how that derivative is actually figured out. What I would recommend is just memorizing it. While the derivative of natural log of x is just 1 over x. So this is going to be 1 over natural log of 2 times 1 over natural log of x, which is just the same as 1 over x times natural log of 2. So this is the derivative of this. Or I'm sorry, let's not go with that. Let's go with this. So natural log, or log base 2 of x, the derivative is 1 over x times natural log of 2. If you change your base here, that's just going to change whatever you're taking the natural log of here. So if you're taking the derivative of log base 10 of x, it would just be 1 over x times natural log of 10. So now what we want to do is, so like I mentioned, actually this formula is also one of the formulas on my study guide. But I wanted to show you kind of how you could figure that out instead of saying just memorize that formula. Generally, it's kind of a good idea to, have an idea of how these formulas are actually derived or figured out rather than just blankly memorizing formulas. So what we had here was log base 2 of x. Log base 2 of x. We figured out the derivative of that thing, back to our kind of product rule formula here, is 1 over x times natural log of 2. So we'll say g prime is 1 over x times natural log of 2. So the product rule says once we have our f, our g, our f prime, our g prime, we just need to multiply these across and then add those two products together. So the original of one times the derivative of the other one, the derivative of the first one times the original second one. It doesn't really matter what order you do these, right? We could do f prime times g plus f times g prime, or vice versa, as long as you're making sure to multiply the derivative of one times the other original. And same thing with the other kind of pairing. So if we're doing that, let's say we take f times g prime first. So we get x cubed times 1 over x ln 2. So y prime is going to be x cubed times 1 over x ln of 2 plus the derivative of that one times the original of this one. So 3x squared times log base 2 of x. Okay, so now we can simplify this a bit. So we have x cubed, and then we're dividing by x right here. So this x is going to cancel with one of these x's, just giving us x squared. And then we can multiply this onto the numerator here. So that gives us x squared over natural log of 2. And then over here, there's not really any simplifying to do with that piece. So it would basically just be 3x squared times log base 2 of x. And that's going to be the derivative based on the product rule formula. Well, I hope you found this video helpful, and after watching it, you're feeling a little bit better about using product rule and also finding the derivative of logarithmic functions other than natural log. If so, do me a favor and hit that like button down below. It's a huge help to my channel so I can keep making more videos like this. And if you want to keep learning about derivatives, just go ahead and click on one of those videos over there. Thanks, and see you next time.